Ready, steady, go!
It's time for Maths with Mr. Thomas.
Yes, it is, and here we go with the start of the Trigonometry and Bearings chapter. And to begin with, what we're starting with is just some revision from National 4. Woo! So we're going to start off with just some revision of SOHCAHTOA. Are you ready? Let's do it! So, you already know if you have a right-angled triangle and you have one of the angles marked, I'm just going to use X. If you have X marked in your right-angled triangle, you can label these three sides. Let's go through them. Moksha! What do you call the longest side? And note that the longest side is always opposite the right angle. What do you call it? The hypotenuse! It is indeed, yes, well done. The hypotenuse is the longest side in a right-angled triangle, and it is always opposite that right angle. High five, Moksha! Woo! Daniel, the side that is opposite X, what do we call that side? There is angle X. We're looking for this side that is opposite angle X. What do you call it, Daniel? It's the opposite. It is indeed, yes, it is the opposite. And it's called the opposite because it's opposite the given angle. Woo! And finally, the side that is beside angle X. There's angle X and there's the side that is beside it. What is a fancy word in English that means beside? Adjacent. It is indeed, yes. Adjacent just means beside. It is the side that is beside the angle. Whenever you get one of these questions where you have to work out the size of an angle or the length of a side, and it's a trigonometry, a SOHCAHTOA question, you should always start by labeling the sides. The hypotenuse, the opposite, and the adjacent. So let's give it a shot. Let's see how you are with it. In each triangle below, label the hypotenuse, the opposite, and the adjacent. Who wants to give the first one a shot? Jason! Go for it then.
Well, if I've got the right angle up there, then opposite the right angle is the longest side, and that is known as the hypotenuse.
Well done, Jason. Hit me with another side.
Well, if we've got the angle X, opposite the angle is just the opposite.
Well done, so that there is the opposite. I'm just writing OPP for opposite. And the other side.
Oh, well, that's the adjacent. Adjacent just means beside.
Yes, and it's the side that is beside the angle. So that is the adjacent, or edge. I am writing. Good. Well done, Jason. Jason, pick somebody else. Samantha. Go for it. Samantha, let's take another one. Which one do you want? Orange, blue, or green? Orange. Okay, so label the sides.
Well, across from the right angle, it's the longest side. It's the hypotenuse.
Well done, Samantha. That is the hypotenuse. The hypotenuse is the longest side and it's opposite the right angle.
The opposite's opposite X.
It is indeed, yes. There is angle X and opposite that angle is the opposite. It's why it's called the opposite. Best name ever. And finally.
Oh, I'm forgetting. Help me out, Huey.
It's the adjacent.
It is the adjacent, yes, the adjacent. Whoops, the adjacent is the side that is beside your angle. We're very well done, Samantha. Okay, somebody else who wants to help me now. Alan! Go on, Alan. Which one do you prefer, green or blue?
I do the green one because it's like me tail.
Okay, so, Alan, which side is which? Opposite, adjacent, and hypotenuse.
I always start with the hypotenuse. The hypotenuse is the longest side and is opposite the right angle.
Very well done, Very well done, Alan. Yes, the hypotenuse is the longest side and it's opposite the right angle.
Then I would look at the opposite. And the opposite is opposite the given angle.
Good, so we're given that angle X and the opposite is opposite that angle, so that there would be the opposite. Very well done, Alan. Alan, and before you go back to sleep, what is the final side called?
It's called the adjacent.
Very well done. This is the adjacent, and it's called the adjacent because it is next to the angle. Very well done, Alan. Good night. Okay, final one. Who wants to do that? Sophia! Go on, Sophia. What would you have?
Oh, I'm so excited! The side that's opposite the right angle is called the
It is indeed, yes, and I can hardly write with this mouse, but that is the hypotenuse there. Which one is the opposite? Is it this tiny little one or the long one here? Which one would it be?
Oh, it's opposite x, so it has to be that long one.
Very well done. Yes, that is the opposite. It is opposite our angle. Very well done, Sophia. And Sophia, it means then that this tiny little length would be the...
Oh, that has to be the adjacent. Phew, did I get it right?
You did indeed. Well done, Sophia. High five to you as well. Well done, everybody. And for anybody that skipped that nonsense, here's the answers. Woo! Okay, so you already know from National 4 these triangles. So, boom, ka, boom, toa, boom. And these represent sine x, because sine x is the opposite divided by the hypotenuse. Cos x is the adjacent divided by the hypotenuse. And tan x is the opposite divided by the adjacent. For anybody that's unsure, just look, there's an O in the top and an A in the bottom. So O in the top, A in the bottom. There's an A in the top and an H in the bottom. A in the top, H in the bottom. And an O in the top, an H in the bottom, an O in the top, an H in the bottom. You get the idea. Hopefully it makes sense. Woo! SOHCAHTOA. Let's put these into practice to work out the length of a side or the size of an angle. What I've done with these examples is I have 3 examples where I'm using SOHCAHTOA to work out the size of an angle, one with sine, one with cos, one with tan. Then what I'm doing is I'm working out the length of a side by multiplying. Then I'm working out the length of a side by dividing. And then to finish off, I've got some problem solving questions. But for any one of these, whenever you get a right angled triangle and you know it's going to be a SOHCAHTOA, it's going to be a trig question, you should always start by writing down SOHCAHTOA and write it down just as many triangles. Write down SOHCA and write it down like this. So you're writing down SOHCAHTOA. And if you write it down like that, it makes it dead easy, because from there you can know if you're dividing or if you're multiplying. You can think about what you want to find. For the future examples, I will just use this box here and I'll be ticking that. But whenever you start one of these questions, what should you always do, Sahar, to begin with?
You label the sides.
You do, you label the sides. So, across from our angle, we have the opposite. It is opposite our angle. The longest side, which is opposite the right angle, is called the hypotenuse. It is indeed, that is the hypotenuse. And the one that is beside the angle is the adjacent, or adj. That's the adjacent. So, what you do next, once you have labelled your sides, you think about what it is you have or what it is you want to find. So, the adjacent, do we know it? Yes! So you tick A for adjacent. Go up here, change colour. We can tick A for adjacent. There's an A, there's an A. Tick both of them. The opposite, do we know the opposite? No! Do we want to find the opposite? No! So we ignore the opposite. We do not need that. We do not want it. So long, sucker! And the hypotenuse. Do we know the hypotenuse? Yes, we do. We know that is the 7 meters. So, because we know it, we tick it. Only tick it if you know it or you want to find it. What you will find is that you always have one of the triangles with 2 ticks. In this case, SO has 1 tick, TOA has 1 tick, but CAH, there are 2 ticks there. There's a tick on the A and on the H, which means then it is going to be cos that we are using. With this, do we want to find the angle, which is the C, or the S or the T? Do we want to find the adjacent or the hypotenuse? Well, in this example, it is the angle we are wanting to find. So we start off by writing cos x equals adjacent over hypotenuse. Brilliant. Then what you do is you sub in your values. So the adjacent is, it is 6. Good. So we'd have 6 divided by, and the hypotenuse is 7. Brilliant. Well done. Good. You could always work that out on the calculator. You can go doink, 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 doink. 6 divided by 7 equals, and work it out as a decimal. But I prefer just leaving it as 6 over 7. And the reason is I don't have to write down just a big string of decimals. And I definitely don't want to round it because I'll put the final answer out slightly. So I'm just leaving it as 6/7. But that's what cos x is. What we want is to get x just on its own. So how do we get rid of cos? Brilliant, you're really taking the inverse of cos. So we write down x to to get the x on its own, and we are getting rid of cos here, leaving us with x. So on the other side, we would do the inverse cos of 6/7. So we've got cos to the minus 1 of 6/7. And on your calculator, a lot of time that's shift cos or second cos or whatever cos, and it brings up this cos to the minus 1. Put brackets around the 6 divided by 7, or 6/7 is the fraction, and if you work it out on the calculator, donk, 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 you get 31.0 degrees. Why degrees? Because it's an angle we're finding! It is an angle, good, so it will be in degrees. Yeah! Shall we try another one? Let's do it. Example 3, again finding an angle. So we've got a right angle triangle. We know it's a SOHCAHTOA question. We are wanting to find this angle. How do we start it off? What do we do? Label your sides. Good. So across from the right angle, the longest side is called the hypotenuse. Good. So we've got the hypotenuse. Across from our angle, we have the... Good. It's the opposite because it's opposite our angle. So that is the opposite. Good. And the one that's beside the angle is called the adjacent. Very well done. The adjacent. After that, write down SOHCAHTOA. Write it down as mini triangles, just the way we did in this last example. Write down SOHCAHTOA as 3 little triangles. If you do that, I'm just going to use the ones here, but you then tick off any of the sides that you know or you want to find. So what would we tick here? Help us out, Abdul. Well done, good. The hypotenuse, we know the hypotenuse is 17 meters. If we know the hypotenuse, we tick H for hypotenuse. There's an H, there's an H, there's no other H's. What else do we know? Yeah, we know the opposite's 11, so we can tick O for opposite. We know the opposite. We know the opposite, so we can tick the O's. The adjacent, do we know the adjacent? Do we want to find the adjacent? No, we're not asked for that, we're asked for the angle. It's nothing to do with adjacent. We can forget about that. Once we've done that, we use the side with we use the triangle with 2 ticks. So in this case, is it so, ka, or doa? Yeah, this one here has the 2 ticks. There's a tick on the O and the H, so we are using sine X. What do we want to find? The angle, the opposite, or the hypotenuse? The S, the O, or the H. Good, it's the angle. The angle is going to be S for sine X, the sine of our angle. So start by writing that. So sine X equals the opposite divided by the hypotenuse. If you put your numbers in there, Nazdar, what would you have? What would the numbers be? Good, it's the opposite divided by the hypotenuse, so it is going to be the 11 divided by 17. Well done, Nazdar. Nazdar, do you want to do the next bit? Because you were so good at that. Yeah, to get the x, you would have sine to the minus 1 of the 11 over 17. Remember, it's the inverse sine. That just leaves us with x on our own. Make sure when you're writing it, you don't write sine x, just change it to x. When you're changing it to x, you're taking sine to the minus 1 of the other side. So sine to the minus 1 of the 11 divided by 17. Key that into the calculator, doink, 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 and you end up getting 40.3 degrees. As usual, just round your answer to either 1 or 2 decimal places, unless you're asked for something else. Should we try one more with the angle, and then try something else?
Yes, please.
Okay, here we go. So once again, work out the size of the angle in this triangle here. So it is a right angle triangle. We're wanting to work out the size of an angle, so we know it's going to be SOHCAHTOA. How do we start this off? What do we do?
Label your sides.
We have to label the sides. So across from the right angle, our longest side is called the hypotenuse. Well done, that is the hypotenuse. It's the hypotenuse. The side that is across from the angle is called the opposite. Thank you, Frank. It is indeed, that is the opposite. And the other side, the side that is beside the angle, the one that's not the hypotenuse, it's not the opposite, is the adjacent. Very well done. Good. That is the adjacent. So, once you've done that, what is that magical word that you write down?
Abracadabra.
No, the other magical word.
SOHCAHTOA.
Brilliant. Well done. Write down SOHCAHTOA. If you write down SOHCAHTOA, write it down just as we mini triangles, and then label your sides and tick off any sides you know or want to find. So in this case, the adjacent, we know what the adjacent is. We know it's 2.9 centimeters. So we can tick any A's that we see. Oh, there's an A, so we tick that. Oh, there's an A, so we tick that. So we tick the A for adjacent. The hypotenuse, do we know the hypotenuse? Do we know that length? No. Do we want to find it? No, we want to get the size of the angle. It's the angle we're asked for. We want the size of this angle. We don't want the length of the hypotenuse. We also don't know it. Oh, so it's nothing to do with the hypotenuse. No, it's absolutely nothing to do with it. The opposite though. Yeah, we know the opposite. We know the opposite is 3.4 centimeters. Because we know it, we tick it. So look for any O's. Oh, there's an O. Good, so you tick that. Any other O's? Oh, there's an O. Good, so we tick that. Always look for the triangle with 2 ticks. There should only be one with 2 ticks, unless you have misspelt SOHCAHTOA. And that means there's 1 tick there, so we're not using so. There's only 1 tick here, so we're not using ka. And there's 2 ticks here, so it means it's toa, and it means it's tan that we are going to be using. Do we want the angle, the adjacent, or the opposite? Yes, the angle, so it's going to be tan x equals the opposite divided by the adjacent. So we'd write that down first of all. After that, sub in your numbers. Jason, if you sub in the numbers, what would you have? Brilliant, it's the opposite divided by the adjacent. So the opposite, just have a wee look, opposite, ooh, where's the opposite? Oh, there's the opposite. And it's 3.4, good, so it is going to be 3.4 divided by, and the adjacent, well, the adjacent is this length here, it's 2.9. So it's 3.4 divided by the 2.9. That's going to be tan x, but we don't want tan x, we just want to get x on its own. So how do we get rid of tan? Do the inverse of tan. Good, so it's going to be tan to the minus 1, or shift tan, inverse tan, however you do it on your calculator, of the 3.4 divided by 2.9, and that gives you an answer of 49.5 degrees. Woo! Okay, so that was 3 examples based on just working out the angle using sine, cos and tan. What we're going to do now is work out the length of a side. How do you know though something like this is not a Pythagoras question?
Well, Mr. Thomas, for Pythagoras, that's right angle triangles, but you use Pythagoras if you know 2 sides and you want to work out a 3rd side. If you take, for example, this one, we only know 1 side. So you can't use Pythagoras because you don't know 2 sides.
Exactly, good. And because there is an angle involved, when there's an angle, you should know that it is going to be in a right angle triangle, so SOHCAHTOA, it will be your trigonometry. So how do you start one of these off? Label your sides! Good, you label the sides. So across from the right angle, we have the hypotenuse. Good, so HYP for hypotenuse. Across from the angle, you have the opposite. Good, so that there will be our opposite. And the one that is beside our angle, there's our angle, this is beside it. The one that's not the hypotenuse or the opposite is the adjacent. Good. Write down the word SOHCAHTOA. Again, just write down as we triangles, SOHCAHTOA. Write down SOHCAHTOA. If you do that, it makes it so easy. With this, what do you then do? Tick off any sides you know or want to find. Brilliant. So we know the hypotenuse. We know the hypotenuse is 5 meters. So because we know the hypotenuse, we tick H for hypotenuse. We tick that H and we tick that H. Good. Tick any of the H's. After that, the adjacent. Do we know it? Nope. Do we want to find it? Nope. So we ignored the A for adjacent. The opposite. Do we know the opposite? Well, no, but we want to find it. Because we want to find it, we have to tick it. So you tick the O for opposite. Again, you have to tick it because it's what you want to find. Which triangle has 2 ticks? So, ka or toa. It is so brilliant. So we'll just put a wee triangle around that, and it is this one that we're wanting to find. Lots of people do this different ways. Some people write down sine x equals opposite over hypotenuse, sub in the numbers, and then rearrange the formula. I prefer not to do that. It depends what you like to do. Do whichever way you want. But what I always do is think about what we're wanting to find. So remember the S, the C and the T, that's for the angle. It's the sine of the angle. It's the cos of the angle. It's the tan of the angle. But what we want to do is we want to think about what it is we're wanting. So do we want to find the angle? Do we want to find the opposite? Or do we want to find the hypotenuse? Well, have a look and see where x is. X here is the opposite, so it's the opposite we want to find. So if we cover that up, just like this, bump, what two letters does it leave us with? Brilliant, it leaves us with S and H. So first of all, think, we are wanting to find out the opposite. Good. And what are we calling the opposite? We are calling that X. So we start off writing X equals. Good. And if we cover it up, well, we're left with another two letters. We are left with S and H. And because they are beside each other, what do? Good, you multiply them together. So it's going to be the sine of the angle multiplied by the hypotenuse. But what you should really do, to save any calculators messing it up, you should put it down backwards. So the hypotenuse was what length? It was 5 meters. Good, so we do 5 times by. And then S, what does S stand for? Sine. Good, and sine is sine of the angle. What size is our angle? 24. Good, so it's going to be 5 times by sine 24. Key that into the calculator, and you end up with 2.03 meters. And that is going to be the length of the opposite. Woo! Here we go, example 6. Work out the length marked X. So, how do we go about doing that? Brilliant. First of all, just label the sides. So if we label the sides, we would have across from the right angle. Good, that is the hypotenuse. So HYP for hypotenuse. Across from our angle, we have the, good, across from the angle is the opposite. So OBP for opposite. And the side that is beside the angle is called the, good, that is the adj for adjacent. Good. So, what do we do next? Good, we write down SOHCAHTOA. So we would write it down just as 3 triangles. Again, write it down just at the side, just the way we did here. SOHCAHTOA. I'm just going to use these ones here. So, what do we then do? Good, tick any sides you know or want to find. So because we're wanting to find the adjacent, we have to tick any A's for adjacent. We want to find it, so we need it. So tick any A. After that, do we know the opposite? Nope. Do you want to find the opposite? Nope. So we leave it. The hypotenuse, do we know the length of the hypotenuse? Yes, we do. If we know it, we tick it. So, we tick the H for hypotenuse. Look for the triangle with 2 ticks. Well, So has 1, Toa has 1, and Ka has 2. So it is cos that we are going to be using. Once again, think about what it is you're wanting to find. So, C is the cos of the angle. So do we want to find the angle? Do we want to find the adjacent? Or do we want to find the hypotenuse? Yeah, just look and see where X is. X is just over here. It's at the adjacent. That is what we are wanting. So, because we are wanting to find X, we're writing X equals. And that is the adjacent. So, if we take our wee SOHCAHTOA triangle and we cover up A for adjacent, we will find that we're left with C and H. And because we're left with these 2 letters that are beside one another, when they're beside one another, we multiply. But remember, just do it in reverse order. So, the hypotenuse, what length's the hypotenuse? 17, good. So it's going to be 17 times by C. And C stands for cos. Good, so it's 17 times by cos. Cos of what? Cos of the angle, which is 40. Good, so it's 17 times cos 40. Key that into the calculator. Boom, 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 and you get 13.0 kilometers. Yeah! Next one, example 7. Work out the length of the side marked X. How do we go about doing this one? What do we do to begin with? Good, we label our side. So across from the right angle, we have the hypotenuse. Good, so that there, the hypotenuse, HYP. Across from our angle, we have the, good, across from the angle is always the opposite. So we can put OPP for opposite. And the side that we are left with is called the adjacent. Remember, adjacent just means next to. It's the one that's beside our angle. After we've labelled the sides, write down SOHCAHTOA. Write it down just as 3 triangles, the way I did on that example, just back here. After we do that, we then tick any sides that we know or want to find. Emmanuel, what sides do we know?
We know the adjacent is 88.
Good, because we know the adjacent, we can tick A for adjacent. We can tick that one, and we can tick that one, so tick any A's. Do we know any more sides?
No.
Good. What else do we tick?
Tick any you want to find.
What do we want to find? x. See, and tick O for opposite, because that's what we want to find. We want to find the opposite. So if you tick O for opposite, we tick that, and we tick that. And you want to use a triangle with 2 ticks. So has 1 tick, Ka has 1 tick, and Toa has 2 ticks. So we're going to be using tan x equals the opposite divided by the adjacent. Once again, some people like to write that and then sub everything in and then rearrange it. I prefer not to. I just have a think about what we're wanting to find. So, do we want the tan of the angle? So is the angle we want? Do we want the length of the opposite or the length of the adjacent? Yes, the opposite. That's what we want to find. That's where x is. So we're wanting the opposite. And the opposite is called x, so we write down x equals. The opposite is what we're wanting, so we cover up O for opposite. And it leaves us with T and A. If we cover up the opposite and we're left with T and A, we'll see they are beside one another. And when they're beside one another, you multiply. Good. So we've got tan of the angle times by the adjacent. But remember, put it in backwards. So the adjacent is 88. And we multiply it by tan of the angle. And the angle is, good, it's 52 degrees. So it's 88 times by tan 52. Woohoo! If you put that into the calculator, you get 112.63 centimeters, and that will be the length of our opposite. Woohoo! So the first 3 examples were working out the size of the angle. The next 3 examples were you working out the length of a side, but we were multiplying. So it's like the hypotenuse times cos, the hypotenuse times sine, the adjacent times tan. But with these ones, it is going to be dividing. Again, this is just a recap from National 4. So with this question here, again, it is going to be a trig question. We know we're going to use SOHCAHTOA, and we started by labelling the side. So there's the right angle. Across from the right angle is the hypotenuse. It is indeed, that's the hypotenuse. Across from our angle, we have the opposite. Good, that there's our opposite. And the one that's beside our angle, that is not the opposite or the hypotenuse, is the adjacent. Good, so we write down adjacent in the messiest writing ever. After that, we write down the word SOHCAHTOA. So we write it down as little triangles. So we write down SOHCAHTOA. And once we've written down SOHCAHTOA as little triangles, what do? Good, you take any sides that you know or want to find. So you can see here we are wanting to find the length of the hypotenuse. That's where x is. So, because we want the hypotenuse, we take the h for hypotenuse. So tick that h and tick that h. We know the opposite as well. We know the opposite is 4.1. So if you know it, you tick it. Because we know the opposite, we tick the O for opposite. And the adjacent, you will see that we don't know it and we don't want to find it. So this has nothing to do with the adjacent. You'll see that So has 2 ticks, Ka has 1 tick, and Toa has 1 tick. We want to use a triangle with 2 ticks. So because it's SOH, it is going to be sine that we are using. So we think sine is the opposite divided by the hypotenuse. With this one here, what is it we want to find? Do we want to find sine of the angle? So is it the angle we want? Is it the length of the opposite? Or is it the hypotenuse? Which is it that we want to find? Good. We are wanting to work out the length of the hypotenuse. That's where x is. Cover up the h for hypotenuse and we are left with O and S. But you can see that O is at the top and S is at the bottom. So it's almost like a fraction with O at the top and S in the bottom. So that's what we write down. We are wanting to find x, so we write down x equals, and it's O for opposite. What length is the opposite? Good, it's 4.1, and we divide that by S. What does S stand for? Sine. Good, it's sine of the angle. So we do the opposite, the 4.1 divided by sine of this 57 degree angle. 4.1 divided by sine 57. Put that into the calculator. And you end up with 4.89 meters. That's our answer. Next example, example 9. Once again, a right angled triangle. We are wanting to work out this length x. How do we start it off? Good, just label any of the sides. So, this side here, it is opposite the right angle. It's the longest side. It is the hypotenuse. Good, so HYP for hypotenuse. The side that is opposite the given angle is called the, good, it's called the opposite because it's opposite the angle. And this one here that's beside the angle, what's a fancy word that means beside? Good, it is the adjacent. The adjacent is beside the angle. Write down SOHCAHTOA, just the way we did in the last example. I'm just going to use it up here, SOHCAHTOA. Write it down as 3 triangles and tick any of the sides you know or want to find. So, because the hypotenuse is what we want to find, we tick H for hypotenuse. We want to find it, so we tick it. The opposite, we don't know what it is, we don't want to find it, we don't know it, it's nothing to do with opposite, so we ignore that. But the adjacent, we know what length the adjacent is. The adjacent is 700 meters, so if we know it, we tick it. After that, you will see that there is 1 tick on SO, 1 tick on TOA, and 2 ticks with CA. So because there's 2 ticks, we are using cos x equals adjacent over hypotenuse. Again, you could write down cos x equals adjacent over hypotenuse and sub in the values and rearrange it, but I always just think about what you want to find. So, is it cos of the angle? Is it the angle you want? Is it the adjacent or the hypotenuse? Yeah, x is just there at the hypotenuse, so we cover up the h in our triangle. Cover that up and we're left with A and C, which means then that x is going to be equal to the adjacent divided by cos of our angle. So, because A is above C, it's going to be a fraction. So A is the adjacent, which is good, 700 meters. So we put that down. So we've got x equals the 700, and we're dividing that by C, which stands for cos. That's cos of the angle, so it's cos 36. Put that into the calculator, doinky doink doink doink, and you end up with 865.25 meters to a couple of decimal places. And again, just round your answer to 1 or 2 decimal places. Example 10, working out the length of a side. Again, this is going to be a dividing example. So, start off by labeling the sides. So across from the right angle is the hypotenuse. Good, that there's the hypotenuse. Across from our angle is the opposite. Good, so that there is the opposite. 6 is the opposite. And the other side that is beside the angle is called the, good, that is the adjacent. Brilliant. Once you've done that, write down SOHCAHTOA. I'm just going to use this one just up here and tick any sides that you know or want to find. So because we know the length of the opposite, we know at 6 millimeters, we can tick O for opposite. We can tick that O, and we can tick that O for opposite. Because we want to find the adjacent, that's where x is, we want to find A, so you tick A. Good. And the hypotenuse, you'll see you don't know it, you don't want to find it, it's nothing to do with the hypotenuse, so you do not tick hype for hypotenuse. Which triangle has 2 ticks? So, Ka or Toa. Good, it is Toa, you can see that there, there's 2 ticks, so it is going to be tan x equals opposite over adjacent that we are using. Think about what you want to find. Is it tan of the angle? Is it the angle you want to find? The opposite or the adjacent? Do you want to find the angle, the opposite, or the adjacent? Whereabouts is x? Good, it's the adjacent you want to find. That's where x is. So the adjacent, if we cover up the A for adjacent, we are left with O at the top and T in the bottom, which means it's going to be the opposite divided by tan. So the opposite is what length? 6. Good, so it's going to be 6 divided by tan, and tan is tan of the angle, and the angle in this case is 12, so it's 6 divided by tan 12. Put it into the calculator and you get 28.23 millimeters. Woo! So that was 3 examples working out the angle, 3 examples working out the side where you multiply, and 3 examples working out the side when you divide it. Now let's apply our knowledge to some of the problem style questions. So to start with this one, you think, oh, is the area of a rectangle I want to find? How do you get the area of a rectangle? Length times breadth. Good. So the area is going to be length times breadth. So the area would be equal to, well, the length's 18. Good. We know the length is 18. And the breadth, do we know the breadth? No, we don't. So what we need to do is we need to try and work that out. But you'll notice that this black line here is splitting this rectangle in 2. And because it's splitting it in 2, it's giving us a right-angled triangle. So first of all, if we isolate just that triangle, then we can say that we know it's 18 at the bottom, we know that length. Because that's an alternate angle, we know that's 20 degrees, so this also has to be 20 degrees. We could equally have just used this triangle at the top as well, flip it upside down, or just leave it if you like. It doesn't matter which triangle you're wanting, but we're still wanting to work out the length of this side, or this side. So I'm just going to put an X beside this side. That's what we want to know. So we can do length times breadth for the rectangle. So first of all, to work out X, label your sides. So across from the right angle, we have the hypotenuse. Good. So we put HYP for hypotenuse. Across from the angle, we have the, good, that there is the opposite, OPP for opposite. And this side here is the adjacent. Good. So adj. So your adj goes there. Write down SOHCAHTOA. SOHCAHTOA. Write it down as 3 mini triangles. And think about what it is you know or what it is you want to find. So because we know the adjacent is 18 centimeters, we can tick the A for adjacent. So we can tick that. We want to find the opposite. That's where X is. So we definitely need the opposite. So we can tick O for opposite. And you'll notice the hypotenuse, we don't know that length. We also don't want to find that length. So we ignore the hypotenuse. We do not want it. Which triangle has 2 ticks? Good, it is tan. Tan X equals the opposite divided by the adjacent. What do we want to find though? Do we want to find tan of the angle? Do we want to find the opposite? Or do we want to find the adjacent? With this example, it is the opposite we want to find. So we've got X equals. And because we're left with T and A, we can multiply them together. Remember, though, do it in reverse order. So it's the adjacent times tan. So we've got X equals. The adjacent is 18. And tan is tan of the angle. So it's tan 20. Put that in the calculator. Bam, 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 and you get 6.55. Why have I put it down to quite a few decimal places, Abby?
Because it's not your final answer.
Exactly, because it's not our final answer. I'm giving it to a few decimal places. Only round your answer, your final answer, to 1 or 2 decimal places. So we know then that this length here was that 6.5514, and so on. We know that length, but it is the area of this rectangle we want to find. So how do we get the area of the rectangle?
I just told you a few minutes ago. It's length times breadth.
Good, so it's going to be 18 times by the 6.55 blah 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 blah, which gives us an answer then of 117.93 squared centimeters. Woo! Example 12. This is the side view of a garden shed.
Ooh, lovely. Nice shed.
Work out the length of the sloping roof. So, how do we do that?
Well, you can see the roof is really a right-angled triangle. So the best way to do it is to isolate your triangle.
Good. First of all, isolate or identify your triangle. So with our triangle, there is the roof. We know this is 18 degrees. We know we are wanting to find this sloping side, so we can say that is X. But what is the height of the roof? What is the height from here up to here? This is what we want to find.
Well, because you know the whole thing is 2.8 from the bottom to the top. And you know from here up to this level is 2.2. You just take them away.
Good, so we think, what do we add on to 2.2 to make 2.8? Well, you can just subtract. 2.8 take away 2.2 gives us
0.6.
Good, so we get the 0.6 meters. Once we've done that, we've got a right angle triangle and we just want to work out the length of this sloping side. So, label your sides. Across from the right angle is the hypotenuse, HYP for hypotenuse. Across from the angle, we've got the opposite. That there is the opposite. And the other side that is beside the angle is called the adjacent. Good. So, write down SOHCAHTOA. So once you've labelled the sides, tick any of the sides that you know or want to find. So we want to find the length of this sloping side. We want to find the hypotenuse, so we have to tick H for hypotenuse. It's what we're wanting to find. The opposite, we know at 0.6, so we can tick O for opposite. And the adjacent, we don't know it, we don't want to find it, we're not given it. That 18 is the angle, it is not the adjacent, so we don't know the length of that side. So we can ignore the A for adjacent. Which triangle has 2 ticks? Good, it is so. So we're going to use sine X equals the opposite divided by the hypotenuse. What do we want to find here? Do we want to find sine of the angle? Do we want to find the length of the opposite or the hypotenuse? So the S, sine of the angle, O the opposite, or H the hypotenuse. Yeah, you can see that's where x is. X is on the hypotenuse. That is what we're wanting to find. So we're calling that x, so you would write down x equals, and then once you've done that, because you are left with O and S, O is on the top, so it's going to be the opposite divided by, what length is the opposite? 0.6, so it'll be 0.6 divided by, and at the bottom you've got S, S for sine. Sine is the angle, so it's going to be sine of 18. 0.6 divided by sine 18 gives you 1.94 meters. So that would be the length of the sloping side of that garden shed. So that 1.94 meters would be the length of the sloping roof on that shed. Yeah! And final example, example 13. Calculate the size of angle CBD in this funky picture here. So CBD, going from C to B to D, boom, 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 must be this angle here that we are wanting to find. How do we go about doing that? Yeah, well, we're not told this is a right angled triangle, so we couldn't just assume that's a right angle and then use our basic SOHCAHTOA from there. We do know this length, we know that's 33 degrees, we know that's 21, but it doesn't really help us. What we need to do is we need to split this up. The first thing we need to do is just pretend that's not even there and work out the length from C to D. If we work out the length of C to D, well, that there would be a right angled triangle. And the length from C to D we can work out using SOHCAHTOA. So for this, again, opposite this right angle here, that there would be the hypotenuse. Whoops. This length here across from the angle would be the opposite. There would be the opposite, OPP. And this side here would be the adjacent. Adjacent. Write down SOHCAHTOA. And what is it we're wanting? Good, we want to work out the length of that opposite, so we have to tick O for opposite. What else do we have? What do we know or want to find? Well, the only thing we want to find is that opposite, for now. But we know the hypotenuse, so you can tick H for hypotenuse. Which triangle has two ticks? Yeah, so sine x equals the opposite divided by hypotenuse. So because we're wanting to get the opposite, we can cover that up, cover up the O, and we'd be left with S and H. And because they're beside each other, you would times them. So just going to call this missing length, this from C to D. Just going to put that down, and then once you've done that, again cover up O for opposite, because that's what that is. You're left with S and H, and because they're beside one another, you would times them, so it's the sine of the angle times by the hypotenuse. Again, put it backwards so you don't make any mistakes with the calculator. So the hypotenuse is 57, and we're multiplying that by sine. Sine is the sine of the angle, so it's 57 times sine, 33. Again, it's not our final answer, so we just write it down to a few decimal places. But once you've done that, what you'll notice is we've worked out this length from C to D, meaning if we go back to the original question, we were asked to work out the size of this angle, CBD, but now what we want to do is focus on this triangle just on the right. If we take just that triangle on the right, the CBD, that is what we want to find. We're wanting to get that angle. And because of that, we can once again use SOHCAHTOA. So to use SOHCAHTOA, label your side. So across from the right angle is the hypotenuse. Across from the angle here, that is the opposite. And the other side is the adjacent. Tick any sides you know or want to find, so we know the adjacent, so we can tick A for adjacent. The hypotenuse, do we know it? No, we don't know the length of that hypotenuse, so just ignore the H for hypotenuse. And the opposite, O for opposite, do we know the opposite? Well, yeah, we worked that out. It was the CD that we just worked out, so now we know the opposite. You can tick O for opposite. Good. Which triangle has two ticks, SOHCAH or TOA? It is tan. Good. TOA has two ticks, so it's tan x equals the opposite over adjacent. Once again, think, what do you want to find? Do you want to work out the size of the angle? Tan of the angle. The opposite or the adjacent? Good, is the angle you want in this case. You want this angle CBD. So because we want the angle, we start off just writing this formula. Tan x equals opposite over adjacent. Sum in the numbers. The opposite is what length? Good, it was that previous answer. It's the 31.0445. 4. And we divide that by the adjacent, and the adjacent is 21. Remember, it is not tan x we want to find, we just want to get x. So to do that, on the other side, we would have that fraction, but we do tan to the minus 1. So it's tan to the minus 1 of that fraction. If you type that into the calculator, you end up getting an answer of 55.92 degrees to a couple of decimal places. And because we were asked to work out the size of angle CBD, don't finish off by saying x is this. We're not asked for x. We're asked for the size of the angle, so we should say, therefore, the angle CBD is equal to 55.92 degrees. Yeah! There we go, there is a recap of everything from National 4 Trigonometry. That is a recap with SOHCAHTOA. Remember, as I said, it's 3 examples working out the size of an angle, 3 examples with the side when you multiply, 3 examples with the side when you divide, and then 3 more worded problem solving style questions. Hopefully you're fairly confident with SOHCAHTOA. You need to be before you move on to the National 5 work, so if you're unsure about anything, practice this, make sure you can do it. There's a good exercise in the TJ National 5 book, page 70 to 72, exercise 8.1, or there's loads of other places as well. Good luck! Woo! See ya!